So 5.5, we'll talk about 30, 60, 90 triangles today. So on all of our special right triangles, like we mentioned yesterday, 30, 60, 90 triangles, 45, 45, 90 triangles, all of these rules are, the idea here is that they give us a shortcut to the Pythagorean theorem. So we don't have to use the Pythagorean theorem on these triangles. We know these shortcuts. Now, this first part is we're going to do like I did yesterday, where we're going to show where the rules come from. So this first part doesn't have to go in your flip book. This is just kind of setting up the rules. Well, yesterday for the 45, 45, 90 triangles, we started with a square. Well, today we're going to start with an equilateral triangle. So let's draw an equilateral triangle here. Now we're going to do kind of the same thing that we did yesterday. So we're going to say that the side lengths of this equilateral triangle are 2. What do all the angle measures in an equilateral triangle? What are all the angles? How many degrees? They all add up to 180, and all of the sides are the same. So what does that tell us about all the angles? They have to be the same, so that each one has to be 60 degrees. Sides are the same, all the angles are the same. So this is 60 degrees. And I'm leaving this one alone for now, because what we're going to do next is, like we did with our square, we're going to draw this right down here and make a 90-degree angle with the base. Well, if I make a 90-degree angle with the base, what does this red segment do to this 60-degree angle up here at the top? Cuts it in half. So that's a 30-degree angle. What does the red segment do to the base of my right triangle if I go at a 90-degree angle here? Bisects it. So the whole length is 2. So how long would this little piece be? If this whole thing is 2, how long would this little piece be? 1. We're cutting this side in half. So that side length is 1. So now we know 2 sides of this right triangle. Here's my 30, 60, 90 triangle. One side is 1 unit long. The other side is 2 units long. Well, let's figure out which sides we have. What side of the right triangle is 2? Is it, with our Pythagorean theorem, is that A, B, or C? This side. A, B, or C, right? Is it the longest side? Is it across from the 90-degree angle? So what side does that make it? C, the hypotenuse. This is the hypotenuse. That's C. I'll call this side A and this side B. So what we're interested in, just like yesterday, we're interested in finding this side length. How long is side B? So we know that 1 squared plus B squared equals 2 squared, using the Pythagorean theorem. So 1 squared plus B squared equals 4. Subtract 1 from both sides. 1 squared is just 1. So B squared equals 3. Take the square root of both sides to get B by itself. And B equals the square root of 3. So in this 30, 60, 90 triangle, if this side is 1 unit long, this side is 2 units long, and this side is the square root of 3 units long. Now I could go through, like we did yesterday with the square, and do different side lengths and test out the Pythagorean theorem. I'm not going to go through it all again. It's the same idea. What it turns out is that in 30, 60, 90 triangles, whatever this side length is, the hypotenuse is always twice as long, and this longer side is always square root of 3 times as long as this short side. So that's going to lead us to our rule for 30, 60, 90 triangles. And it comes from cutting this equilateral triangle in half. So in your flip book, you might want to write as a reminder that 30, 60, 90 triangles are half an equilateral triangle. So if you get stuck on a problem that has to do with 30, 60, 90 triangle, draw in the other half. That might help you remember how to work the problem. We're dividing this equilateral triangle in half. So our rule for 30, 60, 90 triangles, in words, we're going to say for any For any 30, 60, 90 triangle, the hypotenuse is 2 times as long as the short leg and the longer leg is square root of 3 times as long as the short leg. So we could go through just like we did with the square yesterday and try it with a bunch of different side lengths and then put x in there and figure out that this is always true for 30, 60, 90 triangles. We know the short leg, the hypotenuse is twice as long, and the longer side is square root of 3 times as long. So let's label our 30, 60, 90 triangle in our flip book so we know what we're talking about when we say the short leg, the long leg, and the hypotenuse. So label our parts on in our flip book. So here's our 30, 60, 90 triangle. Like so. So this side is what we're calling the short leg. The short leg is across from the 30-degree angle. The short leg is across from the 30-degree angle. This side is the long leg. It's across from the 60-degree angle. And then the longest side is across from the 90-degree angle, the hypotenuse. So this is how we're labeling our 30, 60, 90 triangle. Got a short leg, long leg, and the hypotenuse. In 30, 60, 90 triangles, the short leg is the key. All of our rules for 30, 60, 90 triangles involve the short leg. We could write more complicated rules that involve the other parts of the triangle. It's just easier to remember one set that has to do with the short leg. Now if I write equations like we did yesterday, I would say that the hypotenuse equals 2 times the short leg. And the long leg is square root of 3 times the short leg. So that's really what we're saying. To find the hypotenuse, we multiply the short leg by 2. Find the long leg, we multiply the short leg by the square root of 3. So we're going to draw some diagrams to help us remember these rules, like we did for the 45-45 method. So in your flip book, you might want to just draw a couple of extra little triangles. I'm going to draw 2 because our rules are a little more, we have a couple more rules because we have, our sides aren't the same. You can open up inside, or you can write it on a separate sheet of paper. And I'm just labeling the sides of these triangles. Short, long, and hypotenuse. So what our rules are telling us is to go from the short side to the long side. We multiply by 2. To go from the short side to the hypotenuse, I multiply, sorry I did that backwards. To go from the short side to the long side, I multiply by the square root of 3. Short side to the hypotenuse, multiply by 2. And then the other diagram is for going the other direction. To go from the hypotenuse to the short side, I'm doing the opposite. I'm dividing by 2. To go from the long side to the short side, I'm dividing by the square root of 3. So because the 30, 60, 90 triangles don't have 2 of the same sides, my rules, I have a couple more rules that I have to keep track of. And our homework tonight is just using these rules over and over and over again. To go from the short side to the hypotenuse, multiply by 2. To go from the short side to the long side, multiply by the square root of 3. To go from the hypotenuse to the short side, divide by 2. To go from the long side to the short side, divide by the square root of 3. And this just gives us an easier way to work with these 30, 60, 90 triangles than using the Pythagorean theorem. Questions about our rules? All right, let's look at a couple of examples. So in all these examples, we want to find the missing sides. So here's our first one. Here's our triangle. And we know that this side is 5. So like I suggested yesterday, to solve these problems, label your sides. So is 5 the short side, the long side, or the hypotenuse on this triangle? 5 is the short side. This side over here, is this the long side or the hypotenuse? This is the long side. And that leaves this side to be the hypotenuse. The short side is across from the 30-degree angle. The long side is across from the 60-degree angle. The hypotenuse is across from the 90-degree angle. All right, now we're just going to use our rules. To go, let's do the easy one first. To go from the short to the hypotenuse, what do we do? Multiply by 2. So the hypotenuse is 5 times 2, or 10 units. to go from the short to the long, what do? Multiply by the square root of 3. So the long is 5 times the square root of 3 units. And we're done. So this would be our answer in simple radical form. The hypotenuse is 10 units. The long side is 5 square root 3 units. The question will usually ask you, give answer in simple radical form or give an approximation. Questions on that example? So we're just figuring out our sides of our triangle and using our rules. So let's look at another one. So for this one, here's our triangle. And for this one, we know that this side is 6 square root 3 units. So we're going to label our sides. So is this side the long side, the short side, or the hypotenuse? Long. That's the long side. This side? What is it? Short? And that leaves this side being the hypotenuse. Now to go from the long to the short, what do? Divide by square root of 3. So the short is 6 square root 3 divided by the square root of 3. What's anything divided by itself? 1. So these cancel. And I just get 6 units. To go from the short to the hypotenuse, what do? Multiply by 2 times 2. So the hypotenuse equals 6 times 2, or 12 units. So again, the short side is the key. Short side is the key to our 30, 60, 90 triangles. We always want to find the short side. If we don't have it, we want to find it. And that'll help us find our other sides. Let's look at one more example. So here's our triangle for this one. And we're going to say that this side is 8 units. So let's label our side. Is this the short, the long, or the hypotenuse? Hypotenuse, this side? Short side. It's across from the 30-degree angle. That leaves this side being the long side. To go from the hypotenuse to the short, divide by 2. So the short equals 8 divided by 2, or 4 units. To go from the short to the long, divide by square root of 3, multiply. The long side is bigger. I have to multiply to make it bigger. I'm going to get times multiplied by the square root of 3. So the long is 4 square root 3 units. Now, questions on the examples? Okay, just very quickly, I want to give you a reminder about working with square roots. When I have numbers with square roots, say I have 4 square root 6 times 2. The numbers inside the square roots can mix, the numbers outside the square roots can mix, but they can't go across the square root. So when I multiply this by 2, I'm just multiplying the 4 by the 2. So that's going to be 8 square root 6. if I had 4 square root 6 times the square root of 2. The numbers inside the square roots can mix, the numbers outside the square roots can mix, but they can't mix together. So these two are going to go together, and this would be 4 square root 12. 12 I can simplify a little bit. 4 is, what are two numbers that multiply together to give me 12, where one of them I can take the square root of easily? 3 and 4. So this is 4 times 3. Square root of 4 is what? 2. So the 2 comes outside, so I get 4 times 2 times the square root of 3, or 8 square root 3. Same thing if I divide. The numbers inside the square roots can mix, the numbers outside the square roots can mix, but they can't mix together. And then a quick reminder, if I have something like 4 divided by the square root of 3, what do I do to simplify that? I'm going to multiply the top and the bottom by the square root of 3, and I get 4 square root 3. Square root of 3 times the square root of 3 is just 3. Or I could think these two numbers, they're inside the square roots, they can mix. So I multiply times square root of 9, and I get 4 square root 3 over 3. So just a real quick review on working with square roots. Numbers inside square roots can mix, numbers outside square roots can mix, but they can't mix together. Alright, one quick thing about areas of polygons. There are a couple of questions at the very end of your homework tonight that have to do with area polygons. We're going to go into more detail about area polygons on block day, but I just want to mention really quickly some information today so that those homework problems, so they'll be able to do those homework problems. So in your flip book, there's a section that says area of polygons. I want to add, we're talking about area of regular polygons. So first off, what do we mean? What do we mean when we're talking about regular? What does regular mean when we're talking about a shape? We talk about a regular pentagon. What do we mean about that pentagon? All the sides and angles are the same. Thank you. Regular means all sides and angles are the same. So this part doesn't have to go in your flip book. We'll put more information in your flip book tomorrow. Just really quickly, I want to explain that the formula for the area of a regular polygon comes from dividing this polygon into triangles. And we talked about this with circles the other day a little bit. We divide our polygon into triangles, and then we just add up the area of all of the triangles inside the polygon. So that's where our formula comes from. And again, we'll go into more detail on block day. There are a couple of important parts of your polygon that you need to know for the formula. So you should mark this diagram in your flip book. This piece that goes from the center at a 90-degree angle to the middle of an opposite side is called the apothem. This part that goes from the middle of a side to a vertex is called the radius. our formula for the area equals the apothem times the perimeter divided by 2. And the way we usually write it is AP divided by 2, or 1/2 AP. There are a couple of problems at the very end of your homework where you will need to know this formula, 1/2 the apothem times the perimeter. How do we find the perimeter of any shape? Add all the sides. So it doesn't matter what shape it is. To find the perimeter, we add all the sides. What happens when I make this go at a 90-degree angle to the side? What does that segment do to this side? Cuts it in half. So that's another important thing to remember. This side gets cut in half when I draw the apothem. So the two problems that you'll have to do on your homework have to do with a triangle and a hexagon. So I want to draw those pictures for you. There are a couple of problems, and you have a picture for your homework problem that looks like this. And this is an equilateral triangle. This is the apothem. This is the radius. And this is labeled in your homework. In an equilateral triangle, this little red triangle is a 30, 60, 90 triangle. So for these problems in your homework, you're using your rules for 30, 60, 90 triangles to figure out parts of this triangle, and then you have to figure out the area. The other problem in your homework has to do with a hexagon. And you have the same kind of picture. And these are just like I said, a couple of the problems right at the very end of your homework. And I have the apothem and the radius for my hexagon. This is the apothem. In a regular hexagon, this is a 30, 60, 90 triangle also. So for each of these problems at the very end of your homework, you're using your rules for 30, 60, 90 triangles to figure out parts of these little red triangles. Yes?
Did the end of our homework last night or tonight?
Well, last night it had to do with a square. And so that one was a 45, 45, 90, and that was a lot easier to figure out. These, we haven't talked about these shapes at all yet, so I just wanted to explain about these shapes. On these little triangles are 30, 60, 90 triangles. So on your homework problems, you'll see this shape and you'll see this shape. Remember that you're working with 30, 60, 90 triangles in both of those problems. And we're going to talk more about that area formula on block day. We're going to work more with area on block day. I just wanted to show you these so that when you see them in your homework, they make a little bit more sense. All right. Questions on our formulas for 30, 60, 90 triangles? Okay.